So let's do some practice problems for 8.1. All they're asking here is, so let's find the critical z-value to construct a confidence interval with these certain levels. So for 90% confidence, my critical z-value, I look on my pink table. Is it there? Yes, it is. That's my critical z-value. %98 confidence, I look at the bottom of A3, it is there. So my critical value is 2.326. For 86% confidence, my critical, it's not on this strip. So I have to use my yellow table to get the critical z-value. It's centered in the middle. For 86% confidence, 1 minus 0.86, I've got 14 between the two tails. So I'm looking for the area under the curve closest to 7%, or 0.077 on the negative z side. This number is going to be, excuse me, 8 10,000ths off. This is only going to be 6 10,000ths off. This is the one I'm going to use, negative 1.4, and it's 8. So my critical z-value is just the positive one, negative 1.48 for an 86% confidence. Practice problem number 2, we have a sample size of 49 drawn from a population whose population standard deviation is 4.8. Let's just find the margin of error for a 95% confidence interval around the population mean. So my critical z-value that I'm going to use for 95% confidence is coming from my pink table, 1.960. Now I have everything I need to calculate my margin of error. .960 times 4.8 divided by the square root of 49. So the margin of error is 1.344. If we had a larger sample size, would our margin of error be larger or smaller? So we have the same critical z-value, same population, standard deviation, but now we have a larger sample size. Let's see if the margin of error is going to be larger or smaller. I'll round that to 3 decimal places. My margin of error is slightly lower. It's smaller. The greater your sample size, the more accurate you are, the lower your margin of error. So the greater your sample size, the more accurate you are, the lower your margin of error will become. Number 3, a population has a standard deviation of 21.3. How large a sample size must be drawn so that a 99% confidence interval for a population mean will have a margin of error equal to 2.5. Now we're looking for our sample size. How large a sample size do we need? So the formula we need is solve for n. I have my margin of error, my standard deviation, my critical z-value for 99% confidence is going to be 2.576. So I like to put this in 2.576 times 21.3, enter, divide by the margin of error, enter, don't forget to square it. Now these are a sample size, an item, which we can't have a fraction of, so we round up to the next whole number. B, if the required confidence level was only 95%, would the necessary sample size be larger or smaller? If we're reducing our confidence, is our sample size going to be larger or smaller? So the only thing that's going to change is our critical z-value for 95%. It's going to go to 1.960. So what size sample would we need? So now it's 1.960 times 21.3, enter, divided by 2.5. Don't forget to square it. 86, sorry, we need to round up to 79 to the next whole number. My sample size decreases because my level of confidence is smaller. So if my confidence level is smaller, goes down, the sample size I would need would also go down. If I wanted a larger level of confidence, I would need a larger sample size. So, example 5, we have a sample size of 10. It's drawn from a normal population whose population standard deviation is 2.5, and we have a sample mean of 7.92. We're going to construct a 95% confidence interval for the true population mean, which means we're going to calculate the margin of error, add and subtract it to our sample mean. So let's calculate the margin of error for a 95% level of confidence. My critical z-value is 1.960. My sample size was 10. I'm going to round this to 2 decimal places because my sample mean is 2 decimal places. So I'm going to take my sample mean, I'm going to add and subtract the margin of error to my sample mean. So we are 95% confidence that the true population mean is somewhere between these two values in this interval. If the population were not approximately normal, would the confidence interval constructed in part A be valid? And no, it wouldn't, because my sample size was less than 30. But it was from a normal population, that's why it is valid.